Welcome back, everyone. This particular video presentation is covering material out of Chapter 8 in your book, and the topic of this chapter is arrays. What we're going to do in this video is we're going to talk about the basics of an array, what it is, the theoretical concepts of an array, and talk about some of the different ways that you write programs that work with arrays, and then we'll talk about multi-dimensional arrays and this concept of parallel arrays and give you a flavor of that in a program example as well. So we'll talk about the concepts, we'll look at some examples, and then we'll wrap things up. First off, array basics. In the introduction to this week's Blackboard course topic, I mentioned to you that you can think of a variable like a box. You put something into a box. Just like with a variable, you store something into it. Now, let's say that you have to hold information for a lot of different things. Like, for instance, you have to store a bunch of test scores or a bunch of employees. Now, if I had a situation where, let's say I had 10 students and I needed to get the test score for all 10 of them. Well, one way I could do that is I could enter the score for student 1, and then I could say student 1 equals text window read number. And if I had 10 of them, I would have to do this 10 times. You know what? Let's make it 5 just so we don't get too carried away here. We'll just do 5. Okay, so this would give me the ability to have the user enter in 5 test scores. Now, if I wanted to get the average of these scores, I could do something like this. Now, why am I putting parentheses around the sum of all the variables? Remember the order of precedence is it does addition after multiplication. If you remember the old slogan in school, please excuse my dear Aunt Sally. If you learned it that way, parentheses come first, then exponents, then multiplication, division, addition, subtraction. So if I look at this expression, I have a bunch of additions, and way on the end here I have a division. Well, according to this rule, division is going to come before addition. So what this will do is it'll take student 5 and divide it by 5, and then add the other 4 to it. And that would give me a bad answer, a wrong result. So I need to use the parentheses to group the additions together, and then take that sum and divide by 5. Well, okay, so that's fine. Now, this isn't too bad here. You know, you've got 17 lines of code, right? What if you had 50 test scores or 100 test scores to enter? Now, it's not quite so much fun anymore, right? Because you've got a lot of code you have to write, lots and lots of duplicate code. And you might be thinking, well, why don't you just make a loop out of this? The question is, how would you do that? Because if I made a loop, say I said for I equals 1 to 5, right? Now I could, for the student 1 here, I could come along and write it like this, so that inside of the loop it would say enter the score for student I, and I would be 1, and then 2, and then so on. But what would I do here with student 1? I couldn't really make this work because in the loop, it would always apply to student 1, and I can't dynamically change the name of the variable. So something really isn't right here. I'm missing something to make this work, and that is true. I'm missing something. All I'm missing is the use of an array. And if I simply make this change right here, it's going to work. Now, to do the average, I would need to make a variable called sum, and then start adding itself to every element in the array. Now, student is the name of the array, and if you think of the array itself as a bunch of boxes taped together on the side, let's say, or glued together, however you want to look at it, each box is called an element, and you access the elements based on an index, so that each element has a number, basically. And you use the square brackets to indicate the index in order to get at the particular element. So here, in my loop, I'm saying student, and the way we pronounce this, by the way, is student sub I, SUB for subscript. Student sub I equals text window.read number. So it's going to read the number the user types in. It's going to store it in the student array in position I, which will be 1, and then it'll go all the way up to 5. Now, that fills up the array. Then down here, I'm running another loop that goes from 1 to 5, and it goes and gets from the student array at the index noted by I, and it plugs the I in here, so the first time through I will be 1, and it will get student sub 1, which will be the very first element, this one right here, and add it to the sum. And basically what this will do is I'll add everything up, and then I can divide it by 5 to get my average. Now you might be looking at this saying, well, okay, so you made it a little bit easier, but there's still a lot of code here. Well, you know, if you had 100 students, all you'd have to change are those two numbers. Now, it'll ask for 100 student names. If you want 1,000, now, it wouldn't be very fun for the user to have to type in 1,000 numbers, granted, that is true. But for the sake of the argument, this gives you the ability, just by changing one simple number here, to dynamically fill an array with however many elements you want. Now check this out. This is really cool. You can ask the user how many students there are. So now the program asks how many students are there, the user types in a number, and that becomes the size of my array. So I loop my counter from 1 to size, and I go through. I have an array of students, and I'm going to call this score instead of student just because it's a little bit more descriptive. But you can see here, now it's up to the user to tell me how many students there are. And the loop will accommodate however many they enter in, add them up. Now this 5 here needs to change also to size. And then if I want to print out the average, can do that. So that if I run the program and I say I've got 5 students, 80, 90, 80, 70, and 60, my average is 76. If I put in 20 students, I can do the same thing. Now you can screw this up, right? I could put in how many students, well, I've got 0. Well, I equals 1 to 0 is invalid. It would never run the loop at all. Sum would be set to 0. This loop wouldn't run. Average would equal sum divided by 0, which actually is not a legal operation. But small basic just sets it to 0, and you get the result of a 0. Well, I could even be more devious and put in -9. And again, these loops wouldn't work, and it would just result in a 0. So you have to provide the right data, of course, but the point is it works. For any number of students, this will work. And that's the beauty of an array, in that if you don't always necessarily know how many of something you're going to have. And if you can ask the user for that, then you can write code to accommodate. So that's one of the really neat things about an array. It's dynamic, and it enables you to operate on a set of data without having to create a whole bunch of variables. That's really the beauty of it, ultimately. So we talked about the fact that you can set individual pieces of data into each element. And in most languages, when you create an array, you have to initialize and declare the array. So for example, if this were a program in Java, okay, or C#, I would have to say, okay, I want to create an array of integers called scores, and it's an array of, let's say, 10 scores. Or in Visual Basic, dim scores as integer, like that. So there's different ways of doing this, but the point is that you have to declare the variable, and you can also initialize if you want to. You can initialize a variable, an array I should say. So here I'm initializing an array of scores, and of course in this case I'd only have 4 of them. But again, in small basic, you don't have to do any of that stuff. It's forgiving, and it makes it more convenient for you so that you don't have to do any of it. So for our purposes, we just start using the thing, and it builds it on the fly. Now, most languages, when you create an array, they start indexing them at 0. And they have to. So for instance here, in almost every language, the first element is not 1, it's 0. And so in this particular case, instead of going from 1 to size, I go from 0 to size, and the 0th element is the first element. Now, in those other languages, this is how the expression would actually be written. And what this syntax basically means is you start I at 0, you keep incrementing it by 1, that's what I++ means, and I must be less than size in order to keep looping. So that basically means that if you said you had 5 students, I would have to start at 0, and it would stop when it hit 4, because 4 is less than 5. So I would start at 0, and it would go 0, 1, 2, 3, 4, but not 5. Now in small basic, the way you write this is you started at 1, and you increment starting at 1 up to size. So if they put 5 in there, it's going to go from 1 to 5 inclusive, and it will cover 5 elements because the first starts at 1. Now, in other languages where they started at 0, you can have what's called an off by 1 error. And that occurs if you say you create an you create an array of scores and you set it to 5. And in this example, you would start it at 0 and it would keep going as long as it was less than or equal to 5 instead of just saying less than 5. That would be an off by 1 error. Well, what would happen is it would try to set 6 scores. 0, 1, 2, 3, 4, 5. And that fifth one would be what we call an out of bounds condition. There is no such thing as element number 5. That's a 6th element. And in this language, you can only have up to 5 because of the way you declared it. That's a difference that comes into play when you're working in other languages. As again, I say, in small basic, you start always counting at 1 up to your size and you're covered. You don't have to worry about stuff like that. So it's a little bit more convenient for the programmer. But just to make you aware, when you're reading through the book and they're talking about this off by 1 condition and this fact that you have to start indexing your arrays at 0, yes, that's true in most languages, but just keep in mind in small basic that's not going to be the case. Now, there is something called a for each loop. And in some languages, actually in most languages, when you have an array, instead of drawing up a for loop like you have here, you can say for each. And the syntax differs with this, but you could say something like, for each integer I in scores, like this. And it's just a shorthand way of taking the scores array, looping through it, and every element that it finds, it calls it I. Or maybe it would be better if I said score like this. So it's going to go into the scores array, and it's going to loop through it. For each element it finds, it's going to call it score inside the loop, which is represented by these curly braces. Another feature that is in many languages, and it's nice, it just makes the code a little bit simpler to follow. Now, for our purposes, we have a couple examples I'm going to show you. One of them is a technique for finding an item in an array, and the other is an example of totaling the values in an array and calculating an average. So what I'm going to do here is I'm going to pop up an example that I wrote. This is array 1, and there's also a 2, which we'll get to at another point. But if I just look at array 1 here, this program that I wrote, its purpose is to ask the user how many tests he wants to enter, and then get the values, storing them in an array. Then we're going to present a menu to the user with an option to display the average, high score, or low score. Let me just run this and show you how it works. So you want to enter 5 scores. You put each one in, then a menu comes up. You can say, show me the average, show me the highest score, show me the lowest score, exit the program. Okay, so in the start of the program, I call get number of test scores. That is a subroutine that asks the user how many scores they want to enter, gets the value in count, and this program requires there to be at least 2 scores. So if there's less than 2, it warns them, tells them to try again, re-asks, and then in a loop, it keeps asking until they enter the right value, i.e. any value above a 2. Once I've done that, then I call get all test scores. What get all test scores does is it sets up a for loop, and notice count, which is the number of scores the user entered. It loops from 1 to that number, and then every time it goes through the loop, it gets a test score. As long as that score, which gets stored in an array called scores, at the position notated by index, so it looks at what it put in there, and if what got put in was less than 0 or greater than 100, it warns the user, it tells them to do it again. And it calls get a test score again in a loop, forcing them to get it right. So again, it loops back around until they get a value, a test score, that's between 0 and 100. Get a test score is a subroutine that says enter score, what the index is, okay? And then it gets the number and stores it in the array. That's what get a test score does. Now, get all test scores essentially then gets everything that you need. Now let me go back up to the start of the program, the main block here. So we started by getting the number of test scores, then we get them, then we go to this subroutine called display menu. Display menu is this subroutine. And what it does is it presents a menu to the user, asks them for a selection, reads the number in. Okay, so it presents this menu and it gives them the options. Then it asks them to make a selection. It records their choice. It checks to make sure the choice is in the right range. Okay, so if it's less than 1 or greater than 4, it re-asks, and in a loop. You know what? This isn't right. This should say while instead of if, because I don't want this to be a one-time thing. So while choice is out of range, it asks, and then it repeats until they get it right. Once they get it right, we have a series of if statements to test what they've entered. If choice equals 1, it calls display average. If it's 2, display high value. If it's 3, display low value. And the only other option is choice number 4. If the choice is greater than 0 and less than 4, which means it's going to be 1, 2, or 3, I call display menu, which calls the same subroutine that's currently being run. That's called a recursive call. When you recursively call something, you call yourself, basically. So display menu calls itself. So what that's basically going to do, it's going to show a menu, get the choice, do what it's supposed to do, and as long as the choice wasn't a 4, it's going to rerun display menu again. Now you have to be kind of careful with recursive calls because you can do this wrong and get into a lot of trouble. But with this approach, since there's no code left after this if statement, this will work. It'll just keep calling itself. Now, when the user enters a 4, none of this will happen. This will be no longer true, and it won't call display menu again. So it'll stop calling display menu. Well, there's nothing left to do. So this display menu terminates, bringing me back up to where it came from, where it got called initially. And there's nothing left, so the program ends. So I get the number of test scores, get them all, display the menu, and this subroutine display menu keeps calling itself as long as the user wants to do more stuff. When they decide they've had enough, this subroutine ends. There's nothing left for the program to do, so it stops or quits. Now, back down into the display menu subroutine. So I have 3 things I can choose to do after they've entered the scores. They enter the scores once, then they choose what they want to do, and then I call the appropriate subroutine. Got display average, display high value, display low value. Here are those 3 subroutines. First of all, display average. You create a variable called sum, you set it to 0. You create a loop that goes from 1 to, now notice what we've got going on here. Now scores is an array. I don't know how big it is. The user tells me that when I run the program. So what this array.getItemCount does is it looks at the scores array and just tells me how big it is, or how many items are in it, essentially. So this block of code right here gives me back a number, and that number is the size of the array. Now if you notice way back up here, when we asked the user initially how many scores they wanted, they typed in a number and we said put that number into a variable called count. So if I wanted to use count, I could have put count here instead of all of that other stuff. So why did I not do that? Well, it's better to just ask the array how big it is than to have to rely on another variable on the outside to tell us. You always want to go directly to the source if you can when you write a program. So if I've got an array called scores and I want to know how big the thing is, I just ask it, as opposed to finding some other variable that has the value in it. This is always a better approach to do something like this. Notice in get all test scores, I didn't do that. I used count. That's because the array wasn't fully built yet. This subroutine gets all the scores and puts them into the array. So I couldn't rely on my array to tell me the size in this particular case. But once I have all my test scores in my array, the array is completely built, and then I can ask the array how many things are in it, get the count, and rely on that count never changing. So this sum here is called an accumulator. It accumulates a total, then the average is the sum divided by the number of scores. And then I simply write out the average. So here are a couple other neat things that you can do with an array. For instance, display high value. So suppose I've got an array with a bunch of scores in it, and I'm just going to put a comment here for now. Let's say your array had those scores in it. What we do is we take and make a variable called highest, and we set it equal to the first score. So highest is 50. Then we create a loop, and the loop doesn't start at 1, it starts at 2. We want it to start at the second element and go all the way to the end. We take the second element, and if it's greater than highest, which is the first element, and in this case it is, then our new high score becomes scores sub I, which is 2, which means that highest will be set equal to 60. 60 becomes our new high score. And we loop back up, and I becomes a 3, 20. Is 20 greater than 60? No. So we go to the next one, 40. Is 40 greater than 60? No. We go to the next one. Is scores sub 4, which is 90, greater than highest, which is 60? Yes. So then we set highest equal to score sub I, which is 90. Now our high score is equal to 90. Then we loop one more time. Is 50 greater than 90? No. We exit out of our loop. The highest test score is highest, which will be 90. So that is a way of searching through an array to get the high score, or the highest value. You can also do the lowest value by taking the first score and setting it to lowest. Then you start at the second one, and you just reverse your logic. Now you're saying, is the second score less than the lowest value? Is 60 less than 50? No. So you keep going. Is 20 less than 50? Yes. So lowest is equal to scores sub I, which is 20. Lowest equals 20. Is 40 less than 20? No. 90 is not. 50 is not. So the end result is that lowest will be set to 20. So you can do things like this. Now, a lot of programs have functionality that will do this for you. For instance, in small basic, if I type array dot, notice there's a bunch of methods I can call here. Now, there aren't that many, actually. Some languages will have things like get lowest, get highest, get average. Not all of them do. And if they don't, you have to build it yourself. But most languages have the ability for you to manipulate an array or ask questions about an array like I'm doing here. I'm asking how many items there are in the array. So when you familiarize yourself with a language, it's important to know what you can do with an array. What are your options? What capabilities do you have in working with an array? So this program gives you a sense of how you can use an array to store a bunch of scores. The array is sized by the user. And then you can manipulate the array by getting an average. And then you can figure out the highest value or the lowest value in the array as well. Now in the next video, I'm going to show you another example that uses something called a parallel array. We're going to make two arrays. Not only are we going to ask the user for the test score, but we're going to also ask for the name of the student. And then we can say, okay, not only what is the high score, but who is that person that scored the high score? So we store an array for the scores and we store an array for the names. And they're in parallel with each other. So if I have an array of scores, I have a parallel array of names: Joe, Nancy, Fred, Steve, etc. So then if 20 is the lowest score, and that's at position 3, then the name of that student is at position 3 in this names array. And then I can say Fred has the lowest score. That's called a parallel array, and I'll show you an example of that in the next SB file, the next example. So I'm going to switch over to the next video and cut this one off so it doesn't get too long. But we'll look at that next example here in the next part, and then we'll wrap things up. So we'll see you then.